right, so I'm started recording. There we go. All right, I'm just gonna start a brand new drawing. So blank drawing, and let's see here. We're gonna start drawing the site plan. So again, this will be one of the drawings you'll do for your assignment, and this will be the second drawing, okay? All right, and we're gonna look at it again, okay? And we're going to somewhat analyze it, and we're gonna determine the best way to draw this. So here's our starting point. You know, we look at this, and this has a northeast bearing, right? And if I were to, you know, think of north at the top, east over here, south over here, west over here, right? Then this indeed is going in a northeastern bearing, right? So this tells me that I need to start here, and I need to start drawing my site plan in this direction, right? As opposed to over here where this is a southeast direction. So if I wanted to go from here this direction, that would be a northwestern direction, right? So it makes sense for me to start here and go this direction, okay? So I'm likely going to go northeast, and then this one is southwest, so I probably will draw the rest of this and then come back and maybe do this because that's southwest, yes, okay. So I'll get going on just drawing the actual outline of this first, right? And then we'll go back and we'll talk about how to create the curves. And with that said, I want to say the first step in actually drawing a curved site plan is to draw a straight property boundary, really. So this right here, these dashed lines, these are called chords, okay? We have one right here, we have a second chord here, and we have a third chord there. And each of those chords, they define sort of the length of the arc or this curved portion of the property boundary, right? So we have this chord that is defined just like this. We draw that, and then we're going to use the arc command to create the curve, okay? I guess I wanted to ignore these a little bit first, but we're just going to get into it. So this curve right here, we have a length on it, but we don't have any bearing, right? South 89 degrees or whatever. But we do have a designation. We have a C1 right here. And if I look up here at the, you know, in the top right-hand corner of my page, I see a little table, and it says curve table. And we have C1, C2, and C3, okay? At times, you do see this sometimes, and sometimes you don't, but on a survey, you know, if you have something like this where there is a curve, you can have something like this that, you know, indicates a curve, curve 1, gives the bearing, the chord length, and the radius of the arc of the curved portion you're going to generate, okay? So the information is here, it's just in table format as opposed to being laid out just like this on the page, all right? But still, we're going to follow the process of just generating the site plan first, using these chord lengths, these straight chord lengths, and then we're going to come back and create the arced circles here. Okay. So we're going to start at point 0, 0. Let me split my screen here. Hopefully we can get our bearings here. There we go. Okay. Now I'm back over here in AutoCAD. I'm in a blank drawing, and I want to remind you that when we draw a site plan, we're going to draw it in decimal units. We're going to create some layers that for the property lines, and I forgot to look at what layers we needed to create on this actual assignment, so let's zoom out. Let's see. Create 2 layers, one for the border and one for the chords, the dash line. So we'll have one for this boundary that is solid in this case, and we'll have a second line type for these chords. Okay, easy enough, right? When I look at these lines, you know, I'm not given if it's green or blue or red or whatever, right? But I can tell that this is a very thick line and that this chord length is a thin line, right? So I could say maybe this is red and maybe this one's magenta, right? And there'd be a good difference between those two, and that would give me the quality of lines that I wanted. Okay. So I open up my blank drawing, okay? I know I have to create some layers, but probably more importantly, I need to make sure that I'm in decimal units first. So I'm going to type in units at the command line, enter, And that brings up my units drawing, my units dialog box. Okay. We are going to be drawing in decimal. We draw our site plans in decimal, and then we convert them to architectural, right, by scaling them up by a factor of 12 after we're done drawing them. I'm going to keep my precision like this. I'm going to change my angle, or my angle type, to surveyor units. And we'll change that to, there we go. Okay. So I'm going to hit OK. So now I'm in decimal. I have my precision set correctly. I'm just about ready to draw, right? I just need to create a couple of layers. So I'm going to come up to my layers dialog box here. Oh, see, AutoCAD is remembering not a good template for me. Okay. I already have a layer created, so I'm just going to rename it. We'll call it property boundary. And I want that to be this outer boundary, which will be a thick line. And in this case, it's continuous, right? In the one we did last time, it was dashed or border, whatever, right? So in this case, we're going to leave it continuous, but we're going to change the line weight to a heavy line weight, which is red. And I'm going to create a second layer, and we're going to call it the chords. And we'll make that light, which could be like magenta. And that is a dashed line weight. In drafting conventions, a dashed line weight can be called dash, but it can also be hidden, right? So I'm going to click on line type, and I have hidden here, but if I didn't have hidden there, I would click on load, choose my line weight, and then select it here and hit OK. All right. So we have our line weights our layers created. I need to switch to the layer that I want to draw on, which is this property boundary one. Okay. And now that it is selected, I can draw with it. Okay. So my point of beginning is 0, 0. So I'm going to come over here to AutoCAD, and I'm just going to type, click on line, type 0, 0, enter, and that brings me to 0.00 to start, right? Now I need to, using surveyor units and a dimension, create my first boundary line. So again, like we did on Monday, we're going to type at 187.53 at an angle of north 36D for degree, and you have to have that, 19 minutes, 40 seconds east. Hopefully I don't forget anything. I think the hardest part about using surveyor units is it's not even remembering, but just getting the format right, because you so easily can leave out a north or a west or whatever, and it doesn't, nothing happens. So I hit enter. Something happens, which is good, right? So I zoom out a little bit, but oh, I can't get my cursor to somewhat work to get all the way up there. It's being constrained, and so I have to hit escape and do a zoom extend. So I double click my middle roller button twice, click, click, very fast. Looks pretty good, right? If I were to look at my screen over here, I can see that that is how it looks. Okay. The next boundary line I'm going to create is this one, and that one is in the northwest direction. So I'm going to zoom in on that so we can see it. Okay, L for line or polyline. If you want to do polyline, actually polyline would be better. PL, enter, or polyline here, click. I click, move in the direction I want to go. I'm going to type in my bearing here, and it's going to be at 148.47. And let me just say this, a very easy mistake that you can do when you're creating these is to put the foot mark down here at the command line, and you don't want to do that, okay? The dimension is always just going to be in decimal format because we're drawing in decimal units right now. So 148.47 at an angle of north 57 degrees, 0 minutes, 30 seconds west. It doesn't feel right saying it like that though, does it? Feet in inches. Enter. Okay, we have our second line. Looks pretty good. Okay, we have this little portion of line, and then we have one right here that just says west, right? it doesn't really have a bearing. So that means that it's a zero, you know, there's not an Y change, you know, an up or down change in bearing. So this is going to be a perfectly straight line that has this dimension. But first we're going to do this one. Okay. And I'm going to type at 10.25 at an angle of north 17 degrees, 30 minutes, 0 seconds east. We're getting very confident in doing these. And now I have to create one that's exactly, you know, directly west. So to get an exactly straight line, what command do we use? Ortho. Good. Yes, yes, you guys are getting it. So I'm going to press F8. I could also come down here and turn ortho on with my object snap, right? But it's easier for me, and it, you know, when you get really fast at this, you're going to start using the keyboard a little bit more, right? So I press F8, ortho pops on, and I type 130.28, enter. All right. So I'm going to turn F8 off, and I'm going to continue on with the next bearing. Southwest. Okay, good. So this one's at 25.26 at an angle of south 17 degrees, 6 minutes, 6 seconds west. Okay. Now we get to the point where we have the curves happening, right? And we don't really kind of, at this, how we're drawing right now, we're not going to be very effective at drawing just an arc in the middle of nowhere. And so what we have to do is we have to define this arc using a chord length. And we're going to define this chord length, you know, using bearings and a dimension, just like we have with everything else, okay? But that information is not found right near the property line or the chord right here. It's found in this curve table right here. So we have chord number 3, which is this area right here. So I'll put it off the screen just because I can't see it very well, but we'll type that in. And it's going to be at 26.22 at an angle of south 39 degrees, 33 minutes, 29 seconds east. Enter. Okay. So that seemed to have worked. Right. I have another chord length I need to create, and it's this C2 right here. And C2 is defined right here. Okay. So I'm going to come over here, I'm going to type at 78.24 at an angle of south 41 degrees, 9 minutes, 52 seconds east. Enter. There's my second chord length from using the curve table. And then I have my third chord length right here, right? And that's C1, that's going to be this on the curve table. Okay, so I come back here, I'm going to type at, let's see, 39.80 at an angle of south 25 degrees, 23 minutes, 5 seconds west. Enter. Okay, still looking pretty good. And now, you know, your inclination is, well, what do we do with these curves now? Well, we're going to finish drawing the property lines, and then we'll come back and do the curves last. All right. So I'm going to, oops, I'm going to draw that last property line there. It's going to, and again, it's always very tempting just to want to come down here and join, but again, you want to verify all this information, right? So that if something is wrong, that you can fix it before on paper before it's actually built, right? So we're here, we're going to type at 141.07 at an angle of south 43 degrees, 24 minutes, 9 seconds east. Enter. Escape. And I think this one is, does this one pretty, nope, that one misses just slightly as well, but that's all right. We're not going to worry about it today. Close enough for us. So in general, we have almost all the property lines done. We have one more that goes from here to here. And again, it's very tempting to just want to draw it, you know, from side to side, but just knowing that things go wrong and that we need to verify all this stuff, we're going to draw it, right? And I look at this and it's in a southwest, it has a southwestern bearing. And so, you know, southwest is that direction. So if I draw it from this point to there, it would make a whole lot of sense, right? Yep.
Trying to draw the property line.
What's that?
I go to this place, right?
Yep.
So, and from the thing right here, which we just put in to make it 124, that's it.
No. So that one is C2 right there. And so it's going to be that bearing right there. Yep. That makes sense? Maybe, I don't know. Okay. Yeah, remember the curves, it is a little bit confusing because with this one up here, right, it said 130.28 and it just said west. And you're like, well, oh, since it's just west, we just type in 130.28. And this one just says 26.22. But they're not the same, right? They definitely have a bearing associated with them. And so for these three areas, 1, 2, 3, you look at the curve table here to find the bearing. Okay. We have one more to go here. Let's see. We've got this guy here, L for line, and I'm going to click. I'm going to type at 191.38, oops, at an angle of south 86 degrees, 12 minutes, 55 seconds west. Enter. Oh, and it worked, which is always a good sign. Right, so we have all of our property boundaries created, and everything seems to be working pretty well, which is good. And now it's time for us to create the arced property lines. Now, the arced property lines, they're going to be on this red layer, which is the boundary line. But one thing I want to point out is that these chords are on dash lines, right? And I drew them on red lines. And not only did I draw them on red lines, this was a polyline, right? So they're all attached to each other. So if I now wanted to go back and change, this property line to the chord layer, it would change that entire line, right? And so what I'm going to have to do here is I'm going to have to explode that line and then just change the chords to those dashed layers, okay? So I'm going to have to explode, select those lines, hit enter, and it breaks them down into individual pieces. So now this can be on its own layer, that can be on its own layer, this can be on its own layer, right? The magenta layer, I guess I should say. And the rest of these can all be on the red layer. Oh. Let's grab these. These are on the red layer. That's on the red layer. So there we go. Okay. The chords aren't showing up dashed yet. We'll get to that, right? It's an LT scale issue. And so we'll set the LT scale once we determine what this needs to be plotted at, what scale this needs to be plotted at. All right, so now it's time for me to draw these curves, okay? These curves are generated using the arc command, and they are generated using this radius given in the curve table. So curve number 3 has the arc has a radius of 16 feet. Curve number 2 has an arc radius of 55 feet, and curve number 1 has a 55-foot arc radius as well. Yep. So the property boundary, this boundary is just continuous. Oh, the chords, it's hidden.
Okay.
Yep.
So the last part that says 39 degrees something.
This one?
No, the one for the C1.
Yep.
Okay, do we just, you said I should just put in 39, the C1 thing there, right?
It's right here, yep. 25, that one right there.
Okay.
You see that?
Yeah.
Okay. All right. So what I'm going to do now is to generate these curves is I am going to use these curve tables, maybe I don't think I can get it on the same page without it. So we'll just flip back and forth between AutoCAD and, or maybe it will just very nicely stay right there. Good. Okay. So what we're going to do now is we're going to take, curve 3, and we are going to use a 16-foot radius to generate it. Okay. Curve 3. Yep. And this is curve 3. Okay. And essentially what we want to do is we want the arc to go from here to there. Right? We want this arc to go from here to there. I want to show you something. I want to remind you of something. Well, first of all, we're going to use the arc tool. And we're going to use the start. We want start, end, and radius. That's the one we want because we have a start point, an end point, and we have a radius from the curve table, right? So start, end, radius. Click. Okay. So if I start down here, click, and I end here, click, and I give a radius of 16 foot, enter. Oop. Oh, 16, just 16, sorry, 16, enter. I get an arc. But, do you see what's happening? It's the wrong direction, right? Because when I start here and I move here, I'm essentially going in a clockwise direction. And I need to go in, or I'm going counterclockwise. And in order for me to get it to go the other direction, I need to go in a clockwise direction to get that to work, right? I feel like this, again, I don't like arc, we all know that. I think this is why, number one, I don't get it right all the time, right? But number two, the directionality of it, for me, doesn't make a whole lot of sense, right? Like I get that I can click here and I'm kind of moving this direction and it's going counterclockwise, right? I kind of get that. And I kind of get that if I'm moving this direction and I'm going here, then it's moving clockwise, right? So it's moving in the positive direction. I get that, right, inherently. But for me to stop and think about it, honestly, I confuse myself. I think, is it clockwise or is it counterclockwise, or am I thinking about it right? Is it, going the right direction? So when you're first starting this, I think maybe just the best advice is that it's going to work you have a 50-50 chance of getting it right the first time, right? So if you start at the bottom and go to the top, right, obviously it went that way. But if you start from the top and go to the bottom, it's going to go the other direction, right? So if you don't get it right the first time, my advice is just to do it the opposite way that you did it the first time. Okay, it's the easiest way for me to think about it. Yep. Yes. Yep. Let's do it again because it's wrong, right? All right. So we are going to use arc again, and it's going to be start, end, radius. And this time we're going to start at the top, click, end at the bottom there, click, and then we're going to type in our radius, which is going to be 16, enter. Okay. Yeah, they slightly don't meet.
But this one so over.
Oh, then it's wrong. You have to redraw it. Yeah, that's wrong. You gotta redraw that. Yeah, that's okay. It's okay.
Oh man.
Uh-oh. No, wait, stop. Don't do anything. Oh no. Shoot. It's done for. I'm sorry. No. He hit undo one too many times and it got rid of his entire site plan. Sorry, I had to redraw that. I tried to get it back to redo, but it wouldn't come back. Well, you can watch. You can draw it again. It's okay.
I'm already lost.
Well, you were able to do it. It's okay. You can watch.
Like, you already went farther than I am where I am, so
Yeah.
like, to catch up is.
Oh yeah, not right now, but you'll be able to for homework. You'll have to draw it.
I know, but like, how did you do get this part and this? I didn't see that.
Oh, I just followed the bearings on the instructions. Yeah. Right. So I started here and I just typed that in and it drew it all the way to the end.
Okay.
Yeah.
So how did you do this one?
So this one is one line. That's a second line. That's a third line. Right. And this one is C3, which is over there. C2 over there, and C1. So I just very literally drew this property line.
Okay, so you just
Yep.
attached it to the layer, the second layer.
Yeah, so I went to that point, I hit escape, Okay.
So whenever I try to read the arc, it just does like a solid half circle.
Okay.
Not really consistent.
Let's do it again. Okay, follow me exactly when I do it. Okay, you ready? So here we're going to do arc, and we're going to choose start, end, radius. Click. Okay, I'm going to start here, click, end here, click, and then I'm going to type 16, enter. Did that work?
Yeah.
Okay.
So, sorry.
Why don't you just watch?
I'm trying to walk
And then we
around
can-
it again. The 16, where did you get 16 from again? Is it on?
Oh, it's on the curve table. Yep, so this right here, so 16, that is C3. Do you see that? So we have C3 right here. You see that? And C3 here. This says the radius. Yep, yep. Okay, so we need to do another arc right here. This is C2. C2 is 55 feet, right? So when I draw my arc this time though, right, I started here, I ended here, and it created an arc like that. So for this one where it's gonna be on the opposite side, right, I'm gonna start at the bottom. I'm gonna start at the bottom, I'm gonna go to the top, and it's gonna generate the arc on the other side. So I'm gonna go to arc, start, and radius, okay. Click at the bottom here, click at the top, click, and then I'm going to type 55, enter. Right? It depends on where you start and end it, how it forms the arc, right? So here I started at the top and went to the bottom, and it formed it this direction. Here I started at the bottom and I went to the top, and it formed it right there. So I'm going to do the same thing on this last arc. Start at the bottom, go to the top, and it will form that arc on this side. So C1 right here, right, it has a 55-foot radius. Okay, so I click on arc, bottom, click, top, click, 55, enter. Make sense? Okay. So I have all of these things generated now, right? And that's really how you're going to go about it, right? So the way that we started here, we looked at it. We started, at the point of beginning. We drew the property boundary from here to here, then from here to here, here to here, here to here, here to here. At this point, I hit escape. I changed my layer, and I drew this dashed line using a different layer. So I drew that one. It's C3. C3 is defined by this chord angle, this bearing right here. I drew C2, which is defined right here, right? And then I drew C1, okay, right there. I hit escape, changed my layer back to this solid line, and I drew this final boundary according to this, all the way to there, right? At that point, we had the outer boundary entirely drawn, and then I decided, well, I want to finish up this property line, so I came up to here, and I drew this line across here, okay? Now, my final step was to draw the arcs. Yep.
When you zoom in on the, in between like C1 and C2, is it supposed to, like, are they all supposed to connect? Mine's kind of off.
Oh, oh no, it's on, it's on. The chords are on, right? The arcs misses it slightly. Looks like did I not quite hit that boundary?
Mine looks even different than yours.
I must have snapped to a different boundary. They should meet there, yeah. What's that? Oh, did it? Oh, and I didn't notice. So it looked like I snapped to something accidentally. But yeah, they should all meet at that corner.
Okay.
Yep. Yep.
A little bit after you start from the start point and draw your first line,
Uh-huh.
then do you make the line that's like in the middle, or do you do the one that's kind of going diagonal?
Right. So I did the line that went up diagonal, and the reason I did that, well, I mean, you could have drawn this one across here, right? Because it's going, the things that I look at are which direction is it going, right? So this is going southwest, and this from here to here is southwest, right? So if I would have drawn it, great. It wouldn't have made any difference. But I just decided to continue on and finish all this other stuff so that when I drew this one, it was kind of meeting another point, and I knew it was correct. Yeah. Now there's going to be cases where you look at it and you think, well, maybe this was going northeast instead. So if it was going northeast, it would make sense to draw it from here, right? Because this direction is northeast. So when I type that bearing in, the line would go start from here and go that direction had it been opposite, right? Okay, so now I look at it. Yep.
So on that intersection right there,
Mm-hmm.
when you want to snap your arc, do you want it to snap to the chord line or the actual intersection?
You want it to go to the end point of the chord.
Okay.
Yes. Yep. Because the chords are what are defining it. Yep. All right. So now what we're going to do is we're going to look at it and we're going to see if we can print it.
And how do you do that thing again to make, like to see like the dashes?
Yes. So that's going to be part of the next step.
Oh, okay.
So I'm going to look at this and it says on the instructions, it says, let's see, determine the plot scale required and plot on an 11 by 17 inch piece of paper. Great, right? Okay, so now it's time for me to print. I've drawn the site plan, right? The last step in all of this, well, actually I have two steps. Don't forget to scale it up by a factor of 12, right? I see that time and time again when I go to grade assignments. You've drawn it perfectly and then you forget to scale it up by a factor of 12, right? Which makes it incorrect. So what we're going to do next is we're going to scale it up by a factor of 12. So I'm going to come up here to scale, click, grab the entire thing, bless you, hit enter when I'm done selecting, and down here at the command line it says specify a base point, click, and I'm going to type 12. 12, enter. Okay, so now, you know, again, I like to draw a little line usually. Biggest mistake, students forget to scale it up, right? So it's not the right size. Second mistake made here, students scale it up more than one time because you look at it and you think, oh, dang it, you walk away, get a drink, come back, and you're like, oh, did I scale it up by 12? I don't know, I can't remember, I don't think it looks the same size. How do you tell, right? The way that you can tell is you can measure it, all right? So I'm going to do distance. I'm going to click, click. Now here's something tricky, right? The distance is 2250. All right, well, that's not right because it's in decimals. I'm going to change this to architectural. If this is an architectural unit and I measure that again, distance, click, click, I get 187 feet, which if I look at my assignment, 187 feet, right? Okay. It's tricky, right? And I kind of like to show you every possibility that can happen so that, you know, you're not freaked out and can't get it right because you don't know what to do. But if it's an architectural and you measure it and it's the same as on the site plan, then you know you've done it right. If it's an architectural and you measure it and it's really, really, really small, like by a factor of 12, right? Then you need to scale it up by a factor of 12 and it will be correct, okay? So we've scaled it up and it's time for us to print. I know that these chord lengths, they should look dashed. They don't right now, and it's because of our LT scale, right? You probably know you have to set your LT scale to make them look dashed, but I don't know what my LT scale is until I determine what my scale factor is, right? So to determine my scale factor, File, Plot, or I could type Control P or Print at the command line. I'm going to choose my PDF. The instructions wanted in 11 by 17. I'm going to choose window. Right, here's going to be my window. Center the plot. Now I'm going to uncheck fit to paper, and I'm going to choose some scales that I think might work, right? And when you first start doing this, you have no idea. You're like, 1/2 inch? I don't know. 1/16? I don't know. So it's really a guessing game until you get a sense of what's happening, right? But I'm going to choose 1/16. Oop, that's kind of big. Open its landscape. I'm going to change it to portrait. Still too big. So let's do a 32nd. A little small, but not bad, right? 16th was too big. So 32nd is good. I'm going to preview it. Okay, that looks actually pretty good. I'm going to hit escape. Now I know that, my scale factor is 1/32, right? I'm going to apply that to layout and hit cancel because I want those lines to look dashed. And now I know 1/32 is my scale factor, right? So if I go back to my book, I'm going to go all the way to the end. Okay, 1/32. Well, I don't have 1/32, right? But the rule for LT scale is that it's going to be half the scale factor. Half the scale factor for 1/32 is 1/16. So 1/16 is 192. So I'm going to type in LT scale. I'm going to type in 192 for the scale factor, even though it seems like a big number, right? I get it. But it's correct because this is a big object, right? It's 150 feet long. So scale factor 192, enter, and I start to see my lines dashing like they should. Okay.
So do you have to select the lines first before you do the LT scale?
Nope, LT scale is just it's a system setting, so it's a toggle. So when I change it, it just changes everything in model space. Yep. But it doesn't affect these lines because they're not dashed. Yep.
My plot thing marker can't get okay. It says I need a plot device.
Do you have a printer chosen?
No, what do I choose for that?
It is, let's do it
Oh, Adobe PDF.
right here, yep.
Okay.
There you go. Okay, so I'm going to preview that. Now it looks like it should, right? I have a very thick outer boundary. I have a thinner chord boundary. These are all dashed, of course, right, as they should be. Now, again, my kind of methodology for LT scale is that I choose half the scale factor. I set it to half the scale factor. If that doesn't work, then I do half that number. And if that doesn't work, I do half the number again and half again until it works, okay? LT scale isn't something that is going to mess anything up, right? I said this last time. It's just a view setting essentially in AutoCAD. It doesn't scale a scaled scale. It doesn't scale the scaled object. It doesn't, it doesn't mess anything up. So you can change it 50 different times and, nothing is being affected really in AutoCAD, okay? So I look at this, I preview it one more time, I hit OK. I'm going to go to my desktop and I'll just save this as my site plan. And there it is.
There's a part that says the naming of IA layers
What's that?
from the instruction.
What does it say?
Use proper AI names
Yeah,
for civil.
right.
So we have to name the layers for the civil layer.
Right. So Jeff was pretty, yes, it does say that. It says, make sure that you name these according to the proper AIA layer naming conventions, right? So if you have one called the property boundary and one for the chords, right? If you want to find the proper AIA layer names, let me show you where to find them, and then I'll give you my opinion on them. What is it, 159? Okay, 155. Let's see. Okay, so what he's basically saying here is that for the proper AIA CAD layer names for these, right, under civil, if you look down here at property lines, you have C-prop, that would be the name, right? And for the chords, let's see, bearing, I thought we had one that was something chord. It might just be something like, you could probably get away with C property easement or something like that. I thought there was one that was chord. I would accept C prop dash chord, CHRD, chord, right? I understand why he says that in the instructions. I have 2 comments on it. Number 1, if you're an actual civil engineer and you're drawing an actual property boundary, it would be appropriate for you to name them C dash property line or C dash prop chord, right? That makes sense. But if you're drawing an architectural site plan as an architect, if you give layers designations with a C in front of them, then you're essentially creating civil layers that then you're claiming responsibility for, right? And you are not the civil engineer, you didn't go out and survey it, and so anything that you draw is going to be an architectural layer, right? So in this case, you know, I get where he's coming from. These are civil layers, it's a property boundary, but really, kind of in the real world, that doesn't make a whole lot of sense, right? So there's that. Number 2, I'm okay if you get it pretty close, honestly, with the civil layers. I think at this point we're still beginning, right? And I'd be okay as long as you get them called property boundary or, you know, chord lengths, I'd be okay with that for now. So those are my thoughts on that. Okay. So there's one of our site plans, right? That's how we're going to draw arcs on a site plan. So that'll be one of your assignments for today, or that will be due next week, will be to create this site plan with curves, right? You're going to have this site plan that you also have to draw. And let me see, I'm going to rotate this view. I'm going to talk about this, all right? I'm going to talk about it. I'm not going to draw this. I'm going to let you draw it on your own, and then we'll stop our lecture for today and let you work, or if you need to leave or whatever. But I want to just give you a little bit of some hints on this one because there's a few tricks on this, okay? Let's look at how this property boundary works, right? So we have our point of beginning here, and we have a northwest bearing, okay? So if I start, you know, here's northwest is that direction. So if I start drawing right here, and I type a northwest bearing, my line is going to start right here, and it's going to go over that direction to the northwest, right? So what would maybe make more sense with this site plan is that, you know, this line should be drawn from this direction going this way, right? Because it's that's northwest. So maybe this is not the best direction to start drawing the site plan. If I start here and I move this direction, that's a northeast bearing. So, you know, this direction is northeast, so this site plan is telling me start here and go this direction, all the way to there, okay? Now, this is one thing you haven't run into, but you will on this site plan. I don't want it to you know, get you stuck. We have a curve here, curve 22, and I know it's a curve even if it's a very slight curve and it looks like a straight line. I know it's a curve because I have a C22 right there, right? And I have a C22 here. So the way that you're going to draw this property boundary in these lots, you're going to draw a line from here to here. You're going to draw a chord from here to here. And you're going to draw another chord from here to wherever it ends, maybe right there, C21, okay? Then you're going to draw this line southeast, so it does kind of go, you know, southeast ever so slightly. Then you're going to draw this boundary. Then you're going to draw another chord because we have another arc length right there. And then you're going to draw this line, and then you're going to move over this direction, okay? So you're going to go like that, you know, in that direction. How we're going to draw them? So we're going to draw a chord from here to there, and it's going to be chord 22, and this is the bearing for chord 22, right? So when I get to this point, I'm going to draw this line with this bearing at this length, right? And then I'm going to draw this arc with that radius. So there will be a chord from here to here, and then I'll come back and draw the arc after the fact. Does that make sense? Don't get hung up on the term chord. It's just another line. That's all it is, right? But instead of being shown like this, right, it's just being shown in a table format. There's no difference between the two, really. Now, these boundaries right here, these lines that divide the property, right, they go in a southwestern direction. So if I draw it from this point down, you know, it's ever so slightly going southwest, which makes me believe I should start from the top and move down, as opposed to draw from the bottom up, right? So I'm going to draw from the top down. Now, one tricky thing here, okay, and I'm going to start this. So I said I wasn't going to do it. I'm going to start it, and I want to show you something, and then I'm going to let you guys go and work on it on your own. I'm going to create a new drawing. Okay, so I'm going to do a polyline actually. 0, 0, enter. Okay, and then I'm going to type at, I'm going to do this line right here. 183.580 at an angle of north 89 degrees, 80, what is it? North 29 degrees. North 29 degrees, 56 minutes, 4 seconds east. Okay, so I get my first line there. And that looks pretty good, right? I go there. Now I need to do chord length 22. So chord 22 is this dimension. Now here's the interesting thing about this. This is a northwest direction. The chord is defined as being going northwest, which means that if I start here and I move in the northwestern direction, it's going to go the opposite direction. Okay. Now everything else in this problem is if you start here and you move around it, it's going to work out great. All the directions are correct, except for this one chord. Okay, so here's what's going to happen when I create chord C22. I'm going to do L for line. I'm going to click here. I'm going to type at. It's going to be 67.424 at an angle of north 70 degrees, 33 minutes, 55 seconds west. Enter. And it goes the opposite direction, right? And so you're like, well, I typed it incorrectly, but it went the wrong way, okay? Now, the nice thing about this system is that the bearing is going to be the same, whether it is, you know, like the dimension is the same, the chord length is the same, the 70 degrees, 33 minutes, 55 seconds is the same. The only difference between, you know, similar bearings is the north and the west. If this had said southeast with all the same information, it would have given you the same length of line, the same bearing, but would have gone in the right direction, right? So what I'm getting at with this is I can hit M for move, and I can just move this into place, and it's exactly correct, right? Because now it's going southeast instead of northwest, but the line is exactly the same, okay? So for this line only, you'll just be able to move it over there. And if that happens again in the future, you can just move it into place and it will be the exact same line, okay? Of course, this would be a boundary line. This would be a chord length. And then when you're done, right, when you're done doing all of your chord lengths, you would draw the arc. So I would click on arc, start and radius, click, click, 55, or no, 185 here. And there's my arc length, right, because it's 185. So the arc would start there, it would end there, and there would be my arc length. I would draw the whole thing. You guys don't know how to do text yet, and so we're going to learn text, I think, on Monday. So I'll make this due later next week so that you can add text to it, right?
Sorry.
Yep.
Is it required to draw the arc here too? Because what is this? What I'm seeing here, I'm seeing the arc here.
What's that?
Okay, now the C22 part.
Right.
So that's an arc.
That's an arc. Yes, but in order to get the arc, you have to define the start point and the end point, which is defined by a chord length. Does that make sense? Okay. So when I draw this, I'm going to draw this whole thing. I'm going to make it a polyline. I'm going to offset the polyline in to get this easement, right? Then I'm going to probably explode it and offset this top line to get this, you know, road line. Next week we'll learn about text, so get the most of the assignment done, and then when we learn about text, you can add the text to it, right? And you can finish that up. Gosh, I thought I had one more thing I was going to say about this one. Anyway, this one's just more comprehensive than the others, but it's really no different in drawing, so I will leave it at that.